In this part, I will explain on the firmware which I uploaded to the M1 microcontroller. I have set the baud rate as 9600 and the Atmega 328P microcontroller is programmed to work in 16 MHz clock speed. The firmware is included in the zip file. In the main loop, the push button toggle command will be transmitted from M2 to M1. In the variable pin toggle will switch from 0 to 1 accordingly to get input from LDR 1 and 2. When I run this file, we will be sending PWM data continuously from the microcontroller M1 to microcontroller M2 using serial communication. When we simulate this project, a .hex file will be created and we will be using the file location in Proteus for the microcontroller 1 firmware. This part of the video explains the microcontroller M2 firmware. I have imported the essential libraries here at the beginning and I defined the pin 2 of the microcontroller as the push button digital input and pin 6 as PWM analog output for the LED. As usual, the baud rate is set to 9600. Serial communication initializing, transmitting data and receiving data are built in these functions. The main loop of this firmware initializes the serial communication and then transmit the push button value to the M1 microcontroller. M1 receives the data and send the PWM value from LDR1 to M2 microcontroller using serial communication. And these PWM values will be sent to pin 6 LED. Whenever the push button is pressed, the signal will be sent to M1 and the other LDR data will be received by M2. As usually, we will use the .hex file of this firmware in our Proteus simulation. This is the Proteus simulation of the project, and you can see the M1 and M2 Atmega 328P microcontrollers, which use the serial communication using RX and TX pins as here. The LDRs are used in a voltage dividing topology with two definite resistors of 4.7 kilo ohm in each branch. They are connected to ADC pins of microcontroller 1, which use ADC1 and ADC2 pins. In the M2 microcontroller, I used a yellow animation LED at pin 6, which is connected to oscilloscope and push button connected to pin 2. When we run the simulation, we receive this window of oscilloscope and you can see the LED is at full brightness state with 100% duty cycle of PWM. You can see that when we increase the brightness of LDR1, there is no visible change in the PWM or the yellow LED. But when we increase the brightness of LDR2, you can clearly see the PWM signal change as well as the intensity of the LED gets more dimmed. When we increase the brightness, the LED gets more dim and the duty cycle gets more reduced. When we push the push button once, the control goes to the LDR1 which is connected to 24 ADC pin. You can see that however much we increase the brightness of LDR2, we get no change of duty cycle or intensity of LED, but when we increase the LDR1 brightness, the PWM duty cycle gets reduced and the LED starts to dim. Increasing brightness of LDRs further dim the LED and further reduce the PWM duty cycle. This scenario reverses when we push the push button again, and now the LDR2 gets the control over the LEDs and the PWM control. This is a simulation of Proteus.